Hello everyone. Today let's work on LeetCode problem 3228, the maximum number of operations to move ones to the end. So this question is like this. So we are given a binary string s. So binary string means every at every position it is either 1 or 0. So it's called binary string. So we are allowed to perform the following operations. Uh, we can choose an index I from the string, and it is required that the current index is 1 and the next index is 0. Then we can do this operation. We can move the character si. So this is 1. So we move this 1 to all the way to the right until either it reaches the end of the string or another one. For example, for this one, if we choose this position, so we can move this one all the way to here, right? Because we are be reaching another one here. So it means it can move all the way to the right for 2 position, right? So the resulting string will be like this. So we are required to return the maximum number of operations that you can perform. So I think this is a very interesting problem. So the way we can think about this problem is like this. So the difficulty is there are multiple zeros, right? So suppose we don't have 2 0 here, we just have 1 0 here. So this question is just to move the 1 all the way into and change the 1 and 0 at this position, right? So then what is the maximum number of operations? So for each 0, ideally we want this 0 to get this operation between everyone before this position. So suppose we have n ones before this 0, then the final number will be added by this n, and then we can do this count for each 0 position and get the final value, right? So here is the steps we want to do. First, remove redundant zeros, okay? Then for each 0, we calculate how many ones before it. Suppose it is n, then the final result will be added by n, right? That is the algorithm. Let's see how to implement. So we need to remove the redundant zeros. How to do that? We can actually have another string, right? So t, string t, and for each position in S, if t is size, which means t is not empty, and t back equals 0, and S and ch is 0. In this case, we'll just continue. Otherwise, we put ch at the end of t. Okay, then we move all the redundant zeros. Then we will need to get the final answer. So for each position in t, let's say car in t, if ch is 0, then res plus equal to count. Otherwise, count plus plus, right? Then return res. Okay, it seems correct. Let's submit. Okay, this works. So we first remove all the redundant, the redundant zeros. Actually, you do not need to have another string, but this way is simpler, right? So actually, you can use a two pointer, and the fast pointer and slow pointer. You can also remove all the redundant zeros, but we will do it this way to save some time and for simplicity. And then it's pretty clear. So we'll count for every one at the current position. Then if the current position is 0, then res will plus equal to the current count. Otherwise, current count will plus plus. Okay, and I think that's all for this problem. And thanks for watching. See you next time.